Chapter 7, Lesson 2 is vectors. So a vector is basically a ray. So remember, ray from Chapter 1 with an initial point and an arrow is a ray on a graph. So it has initial or a starting point and terminal ending points. So looking at this example I gave here, it asks what is the initial point? Well, the initial point is where the dot starts, so that's 1, 1. And the terminal point is 8, 2. The next definition we're going to have is components of the vector, and they're written as delta x and delta y. And basically what the components are asking is what is the change between the x coordinates and what is the change between the y coordinates. So for this one, for the components of x, I want the change between 1 minus 8, which is negative 7. And then what is the change in the y's, which is 1 minus 2, which is negative 1. Now, when you do the components, though, you have to do, because it's distance, because it's change, we do want it to be absolute values. We want it to be the positive numbers. So we would write it as 7, 1. So we have to do absolute value of that afterwards. All right, next we have the magnitude of the vector, and we have to remember that the magnitude is the same thing as distance. And they write it as absolute value of AB, but we would do the same thing. We would do the distance of 1, 1 to 8, 2. So I would do the square root of 1 minus 8 closed squared plus 1 minus 2 closed squared. And that would give me a distance of 6.9, or a magnitude of 6.9. So in this one, we're going to find the components of the following vectors. So the change in x is 2 minus 4, which is negative 2, but we want to make it a positive. And then the change in y's is 1 minus negative 3, which is 4, which is already a positive. The change in x's here is negative 5 minus 2, which is negative 7, make it a positive. And negative 4 minus 2, which is negative 6, make it a positive. Next, for the magnitude, that's the same thing as the distance. So for this one, I'm going to do 0 minus negative 4 and 0 minus negative 3. Square root is 5. And the next one, 5 minus 2, negative 4 minus negative 2. 3.6. Vector has the initial point A and a terminal point B. Write the components of the vector as an ordered pair. So for the first one, for the change in the x, I would do 2 minus negative 1, which is 3. And for the change in the y, I would do 5 minus 8, which is negative 3, make it a positive, which is 3. So now remember, when they give us the components of the vector, remember this is x1 minus x2. And for the distance formula, that just gets squared and added to y1 minus y2 squared. So they've already given us the parentheses. So when I set this up, I'm just going to set it up as 6 squared plus 2 squared, which is 6.3. This one, same thing. These are my x's. So I'm just going to do the square root of negative 4 squared plus negative 1 squared equals 4.1. Now the next thing they're going to tell us right here is they want us to add the vectors. So when we add the vectors, we add like terms. So for this, I'm going to add the 6 plus the -4. And then I'm going to do 2 plus -1. So when I add these, I'm going to get 2, 1. So basically what that's saying is, let's see if I can remember how to add a graph. Graph paper. Okay. So we have QA at 6, 2. And then I have QB at -4, 1. Oh, man. Okay, let's try this again. 1, 2, 3, 4, 5, 6, 1, 2. And then I've got QB at -4, 1. And they want to see what would happen if I add them together. So when I add them together, I get this situation here, which should be halfway in between the two directors' distances and their value. Okay, the initial point of OR, OS, and OT is 0, 0. The terminal points are the ordered pairs shown on the coordinate plane. Find each quantity. So it wants me to add OR, which is 4, 3, plus OS, which is -2, 4. So I add the x's, which is 4 plus -2, which is 2, and add the y's, which is 3 plus 4, which is 7. OS and OT would be -2 plus 3, which is 1, and 4 plus 1, which is 5. OR and OT would be 7, 4. And when I add all three of them together, that would give me 5, 8. The course of an airplane is described by the vector 12, 2. The wind blows perpendicular to the airplane's course, described by 0, 2. On your own paper, draw P and W on a coordinate plane, with their initial points being 1, 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2. So this one is P. And then I have W, which is 0, 2. Initial point of 1, 1. And this is 12, 2. What are the components of the resultant vector if I do P plus W? So 0 plus 12 is 12, and 2 plus 2 is 4. And what is the magnitude of the resultant vector? So magnitude is distance, so the square root of 12 squared plus 4 squared. 12.7.